Welcome everybody. We're here in the midst of the holidays in Holland, so it's great that there are so many people joining with this webinar. We do these webinars, I think, about once a month on all different AI topics. So I think it would be great if you are looking forward to this one. You will always probably also look forward to the other ones. Today we're going to do a deep dive in AI-assisted development. Some of you might have already read the handbook that Roel, Javier, and Timo have written. Otherwise, you can also look at the handbook afterwards. And Roel is going to start off with a lot of his experience that he's gathered over the past few years. Very important. We're going to do this webinar together. So if you have any questions, real life experiences, or other things you want to share, please do that in the chat. Our experience is that if we do that together and we get a lot of questions, the webinar's quality will increase by a lot. So please let us know where you're curious about. There are no stupid questions. We really want to engage with you. So I hope you will share your thoughts and questions with us. Okay, let's give it a go. Roel, you can go ahead.
Let's dive in. Thank you for being in such a great number. Let's begin where this experiment or the white paper started, because real AI coding started like 2 years ago, and everyone saw the quality that came out of it, and that was pretty horrible to say the least. And well, in the past year, the quality has really bumped, and the amount of code that's being generated by these AI coding systems is tremendous, in such a way that at my current customer, it's really hard to keep up with all the merge and pull requests that we get, and we're just reviewing AI code. So from that perspective, I was thinking, okay, how can we apply our same engineering principles, so writing good quality code that survives production, and apply these same principles to agentic coding. So you guys probably heard the term vibe coding. So how do we go from vibe coding to using these agents to provide quality? So I reached out to Timo and Javier, and together we wrote a white paper on what we think are the best practices for using an agent and letting it contribute to your coding environment. And that's where I coined a term called explicit agentic engineering, which basically comes from the perspective where a lot of information we have is implicitly in our heads. Maybe there's some information that you only know from Bob, who's at the coffee, always talking to you at the coffee machine, or maybe it is from a meeting that happened in the morning. Information that's not necessarily available to your agents. So in the white paper, so you don't have to need to have read it, we will talk you through like how the beginning of a user story begins. So what is the change we want to make to the system, to how do we know that the change that was made is successful, so a reviewable change. But first, let's do a little introduction, who the writers are. So my name was already introduced. My name is Roel, and engineering discipline is for me a really important topic, in that I really want to make sure software systems are maintainable. So not just throw every proof of concept directly into production, but make sure it survives a very long time. So no throwaway projects from 1 year, but it needs to survive the test of time. And I usually take an AI first approach to software delivery. So I try it with the latest agents. I think I have 4 different AI subscriptions. So also to really test which frontier model is the best at the moment, and really experiment with it and how to get the best result. I live in Gouda, for the people who I'm a real stroopwafel guy. So with that random fact, I will give the turn to Javier.
Hey guys, good afternoon. Thank you for you guys being here. It's really nice to see so much people here. I'm Javier. My Well, the topic that I wrote about the most in the white paper was the execution and economics, what I call token economy from the very beginning. I think most of you have had the issue that token sometimes is just not enough if you're not paying enough. And basically, I've seen it in many organizations that there is no discipline on how to actually approach proper token economy and how to tackle it. So that's why we came up with this initiative and this chapter within the white paper. I live in Schipluiden. I think it's the last dorp, last town in the Randstad or close by town. So with my random fact, I'll leave it to Timo.
All right. Yeah. So I'm Timo. I live in Rotterdam. I'm a lead cloud engineer. Lots of experience in AWS, Kubernetes, together with backend development in Python, Golang, TypeScript, and Java, and whatever is the flavor of the week. I do a lot of agentic software development. I do a lot with the local run. Outside of work, I also like vibe coding. My most recent project is my Samsung TV couldn't play subtitles on large files. It really annoyed me. And then I found out the code was actually online. After a day of back and forth with codecs, I now have subtitles. So great, yeah. So I give it back to Roel.
All right, thanks a lot. So the shared question we have, so everyone had their own input in the white paper, but how do we move from agent-generated work throughout delivery without outsourcing our judgment? So how do we, so you probably heard the term human in the loop. Where do we place the human in the loop so that we have a clear intent, but also a clear package we can deliver and review? But first, let's try to make a baseline, because I don't know in the audience how many are developers or maybe product owners or architects. How many of you have vibe coded before or even used agent coding? Maybe you can put a thumbs up in the chat if you do. But to establish a baseline, so what is agentic coding really? So we have these LLMs that can generate a lot of output. So you give it some input, and then it will hallucinate and give you a lot of code. And what these agentic coding tools basically do is they pick those those large language models, put it in a supersuit that is able to use toolings to directly modify files or call other tools, search the web, etc. That's something that we then call agents. So a large language model in combination with toolings, and usually there's also some sort of loop in it. These agentic coding tools like Cloud Code, for example, or Codex, I think Timo just mentioned that. There's also other ones, so like GitHub Copilot. What they do is they observe the code. So based on your request, they will check, okay, which files do I need to reach my goal? And based on the observed code, they will decide the next action. And the next action can be, okay, I can do a modification, or the action might be, okay, I need more context to know what my next action will be. So once it's determined action, it will do an act like the modification or search the file. It will verify the result and then adapt, and it will continue to do this until it reaches its goal. So with older models, we noticed, okay, these agentic coding tasks, they can maybe last up to 20-30 minutes. But now with the newer frontier models, we really see, okay, these tasks, the task limit is moving from 30 minutes to maybe 2 hours, to even longer if you give it a big enough goal. Speaking about big enough goals, that's where the problem for us as a reviewer or as a human in the loop comes in. So the problem is if we give it a one big instruction, we go get some coffee, and once we come back from our coffee, there are codes and there's a lot of code and tests, and it gives a convincing explanation. And of course, we all think, oh wow, I just saved 4 hours of work finishing this user story. But nobody tells us that's when the actual work begins. So we open the pull request, and we suddenly see, hey, an architecture boundary, was broken. 3 components were changed where I initially thought, okay, this should have only affected this one component. There's a lot of extra error handling, and the agent did a lot of assumptions. And then it's up to me as the reviewer. Okay, what was changed? Why it was changed? And is this still matching what my original goal in mind? And that's the hard part. It's not that the agent can't write code. It can write a lot of code very fast. But what for us as a human to be able to verify it, understand it, and judge if the change is valid, that's the hard part. So to get more trust in the delivery of the agent, we have to move into certain principles, which brings us to our central thesis. So what we also see from DORA, DevOps research analysis, research papers, what we already see in the market is that agents amplify engineering systems around them. Meaning, if you have good engineering practices within your development team, they will scale success. So there we see teams that have like 20 to 80% production increase, where we see teams that don't have good engineering practices within their team, they get a lot of faster rework, and we even see production decreases. So how comes one team has an increase and one team has a decrease in productivity? And that's basically the engineering principles we will name in the next slide. So if we do vibe coding in delivered products, everyone's going to know we're going to end up with faster rework. Maybe there are a few tools that are vibe coded that are completely fine. So I don't say don't ban vibe coding, but check if it actually will work in production. But if we move from vibe coding to explicit engineering, we can validate the changes made by the agents faster, and in the future even give the agents more autonomy. And to do this, we came up with an engineering triad that helps us take a look at 3 principles when working with agents to get to reliable agent operations. So one is called prompt engineering, context engineering, and harness engineering. Timo will tell something about context engineering in one of the later slides, and we will move from prompt engineering to context to harness. And then as an overall side, we will also talk about token economy, which Javier will talk something about. So prompt engineering is really about getting your objective across to the agent. So I always say agents are a bit like junior developers with a PhD and a short attention span. So you have to be really clear to them what exactly is in scope, out of scope, and how what acceptance criteria is. And then context engineering is more about providing the right information for the agent to run on, and the harness is all about control and capabilities. But this is an overview. But if you don't invest in one of either sides, then that side will become the bottleneck. So that will move me into what is prompt engineering. And in the white paper, we use prompt engineering or intent engineering. It's really about getting your intent across. And to do that, we've introduced a work definition card. It's somewhat of a template, but of course you can come up with your own template. But what's important is that we define a clear goal for the agent to pursue. So for example, if you're having a problem with expired sessions in login, your clear goal would be redirect expired sessions to log in with a clear message. And if you would make your goal even more concrete, you could also tell the agent, okay, this is the exact message that the user would want to see. Well, in vibe coding land, you would say, okay, fix the expired sessions, and then the agent would assume that it magically knows how to solve your problem. And if you're lucky, it solves your problem. And if you're unlucky, you do 30 retries, and then one of those 30 will solve your problem. Very expensive and not advisable. And so what we then the next step in your work definition would be saying, okay, which part of the of your solution should be in scope. So for example, maybe we only want to change things within the front end, or as a side. So what things are out of scope? Maybe we want to only make code changes, but not necessarily change existing documentation already. Then you can, the next part of the work definition would say, okay, what is your clear acceptance criteria? You could do a Gherkin style where you say given when then, so that you make it really clear what is the behavior that is expected. But maybe if you're already working with user stories, most of you already have acceptance criteria that belongs to your definition of done. And the last part of the work definition is defining stop conditions. I think Javier will also tell something about it during token economy. But we really want the agent to stop with their work when they will make assumptions, or for example, when things get too costly, or there's maybe impact that's not relevant to your current change.
One short question.
Yeah.
This time for me. Can you share an example with us when you really missed the mark on the intent engineering? When you thought you had it okay, but in retrospect you would have had to change it?
Yeah, it's interesting. Usually it happens, not that the intent is necessarily wrong, but that my harness is not fully set up. So I request a change, and then as soon as I go into testing myself, for example, and sometimes it is indeed, hey, I missed an acceptance criteria. And because I think to answer your question, it's also a bit of a loop. So you create an intent, you apply the changes, and then you start testing, and maybe you start testing it with a user. And based on that user feedback, you noticed, okay, my intent was not correct. And then you have to go back and update it.
Yeah.
And an example, so if you have the session card and you put it in a prompt, you only do it once, and then the problem is the reviewer does not know what prompt you made. An example to make this session card durable is spec-driven development. So once you apply spec-driven development, you can apply a template which you basically put in a specification which almost handles this the session card, but it will also do research within your code. Okay, how will this be solved technically? So for example, the newer models, they have a tendency to over-engineer. So okay, I need to have a cache in place, and usually the newer models will say, okay, let's use Redis for that. And maybe I only have a small user base, and it's fine to have it in memory. So what's important from this session card and from spec-driven development is that you as an engineer stays on top of the choices that are made functionally and technically.
Thanks, Will. And one question from Kido. He asks, how large can or will be the scope of the change be? So will it be on a feature level, a PBI level, or task level, for example?
Good question. I also received that question Friday. So depending on the model that you use, so the bigger models can change larger work, which also means you get larger work at the end to review. So that's a bit of a balance, but mostly it's on the level of a PBI. So I would say like 80% of the work you do with an agent is on a PBI level. Then maybe the larger setup things, you can definitely do that on like an epic or even larger level. So I don't know, maybe Timo, how your experience is with this?
Yeah, I also usually keep it to a user story. So something that you could do within, let's say, a day. Because I also feel like as soon as you give it work that would take me multiple days, then I have a really hard time verifying if it's still correct. So for my sake, I usually limit it to something like a day's work.
Yeah, and I think
frame.
To add to that, so if you go in a bigger level and the agent makes a mistake 4 hours in, you have to undo, and it goes on for 4 more hours, so like a day, you have to undo 4 hours of work.
And 4 hours of tokens.
Yeah, exactly.
Yeah.
That's why that stop condition is really important.
So I hope, Guido, this will answer your question all right. But the follow-up question from Guido, but doesn't the setup then just take as long as you're just doing it yourself? I think a question we all are struggling with sometimes.
Yeah. So to answer that question, I could say it depends. So most of the tasks, I do notice a time saving, because of course the setup, you don't necessarily have to write it yourself. This is usually me just brainstorming with another agent about reasoning about a user story. It maybe takes, so for most PBIs, this takes me like an hour to get with a good intent, and then it can produce maybe like a day's of work.
So yeah, so the return on that investment is still okay. Yeah.
But I would say it requires you to write better specs basically than before, since it basically amplifies whatever you did. So before you could get away with writing like a okay spec and then during implementation figuring out what you missed. And now you're really forced to spend more time in that initial phase. Yeah.
Good
Thanks,
question.
guys. Yeah.
So then we move on, because you can write a beautiful prompt, but if the agent doesn't have enough information to complete its request, then you're in problem as well. So we'll give the word to Timo for the context engineering.
Yeah. So yeah, basically context is about giving the agent the truth it cannot infer. And basically out of the box, your agent knows nothing about your weird business terms. It doesn't know you prefer classes over functions. It does annoy me often that, I don't know, maybe you see these posts on LinkedIn where people call these models dumb because they ask it some highly specific answer, and it gives the wrong answer, and they're like, okay, AI is stupid. What I think and what we believe is that the AI is really smart, but maybe you just gave it very dumb information. So in general, there's 3 types of these contexts. The first is repository context. The most common one is the agents.md. You probably are familiar with it. It's a single file, lives at the top of your repository, and it can contain things like domain rules, testing strategies, and also it can use other static files in your repository like API contracts, these kind of things. Important to note is that it doesn't need to be only root context. Like you can have one single agents.md file, but usually you want something more specific, especially if you have a monorepo with many apps. It makes a lot of sense to have a specified file per certain app and maybe only really have certain broad things at the root level. The next is session context, things like Jira information, also your work definition, also which files are relevant for this. It can discover these things. Most harnesses fetch automatically the files you have opened. Sometimes that's enough. Sometimes you can save a lot of time if you say, I want to change this exact file. And the opposite is often also true. And I already know if I ask it a question that's about something completely different than I'm working on right now, it often gets terribly, terribly confused. So there it really helps to really nudge it now, like I'm talking about this exact application and not this one. You have live context, think test output, current git diff, or any kind of other runtime things. I think also MCPs. I mean, this is very, very broad. Can be database calls, can be log calls. I mean, yeah, there's many, many different variations, which is too much to cover here almost. In general, what is the sort of the thread in between them is that the information needs to be there for the agent to access it. So I always go to sort of like a capture, curate, reuse flow. Like you need to capture it because otherwise it's not there. But also you cannot just capture everything. There is this thing as it's called the smart dump zone or context rod. Matt Pocock also wrote something nice about it, which basically means if you just give it all the context, at some point it will just get really dumb because it just cannot handle that much tokens anymore. And also you might have conflicting statements, these kind of things. So it's also very important to curate the information to only store what you really need. And then lastly, of course, reuse it because if you save it and don't have it somewhere where the agent cannot access it, there's no real point to it. All right, then I hand it back to Roel.
Yeah, thanks, Timo. I have a question from Ronald, but it is more on agentic code review. I'm thinking about the sheets that are coming up. Do you want to answer it now or want to answer it later?
I can take it at the end of the slides because then we're looking at a bit at the future. To give a very short answer, so the white paper currently focuses really on the development lifecycle, so really the coding part, and ends at the pull request. I can definitely share some great tips about coding review tools because they're also something we do daily, but that's outside of the boundary of this white paper.
I would in general say, just a short remark, I already have like a personal code review thing. The first thing I do with any review right now is always first have the AI at like max intelligence run the review and only then do the review itself. Because I've already had several times where there's some extremely nitpicky things like some queue or database misconfigured, which I would have never spotted. And the AI is really good at these things.
Thanks a lot.
And Ronald will get back to it in the end of the session.
Yeah, we'll dive deeper into it.
Yeah.
That leaves me to the last part of the engineering triad, and that's basically harness. So most of the coding agents you already use, like Codex, Cloud Code, GitHub Copilot, are their own harnesses, and they come with a lot of out-of-the-box toolings like file edit, web search. Most of the tools have like an inline browser, so I don't know if there are any Codex users out there, but like the current browser or computer users, it's really amazing, and that's a capability the harness already comes with. So when we talk about harness engineering from a paper, it's mostly about like a harness configuration where we can extend the harness with new capabilities. So for example, at my current client, we use like an open source conductor. So that's a it's a Netflix workflow orchestrator. But the problem is, if the agent needs to verify if his change is successful, it needs to know what the status is of the workflow once the code has run. And normally, it can't access conductor in this case. So what we did for our solution is create a specific skill, which is basically a markdown file that tells an agent how to execute certain scripts or make API calls, and then gets that status of the workflow directly from conductor. So that means I eliminate a human in the loop factor where I just the agent executes the code, and previously I would have to go to conductor, copy paste the output, and put it back in agent, which means when including this skill, the agent can go on for longer in its own because it can detect, okay, maybe I made a mistake during the coding, and now I can self-correct that mistake. Other capabilities or verifications it can do is, for example, run lint, or maybe if you have a SonarQube server, it can check the result of that. So on one hand, a harness gives you greater capabilities. On the other hand, the harness should also work like controlled execution. So what code or what tools it shouldn't be able to call. Of course, newer models, they are very creative. They're trying to break out if they really need to reach their goal. But also, okay, when do we stop? And which budgets do you use? So once the agent can safely act within your environment, and safely is also a term which I would say for the task it needs to be done. So you can of course say, okay, it has access to production, now it can do everything. Will that fly with your security policy? My guess is probably not. But for a coding perspective, interacting with your local environment is generally good, so that it can verify its own changes. I see there's a question.
Yeah, I can see a question from Leander. If you have a lot of skills that your agent could use, does it also introduce the smart dumb problem you talked about, or is this a cleaner way to provide a lot of contextual data?
Yeah, so it is indeed a clean way, because what the thing is with skills is they are markdown files with a name and a description. So for example, in my conductor example, it will only load that skill within the context if it needs to do something with conductor. If I'm purely working on front end with React, it will probably load my React skill. Where agents.md, those are configured on either the root folder or subfolders. So for example, when the agent is working on front end work, it will only load the root agents.md and my front end specific agents.md. But perhaps I have a skill around WCAG, so about accessibility. It will only load that skill once it needs to do accessibility work. I don't know if that answers your question.
Yeah, let me check with Leander, but I think your answer is quite clear. Yeah, perfect.
Yep.
Yeah.
So if we have the prompt engineering in place, your context engineering, your harness engineering, how do we so if we give them a lot of capabilities, they can run for a long time, which might be costly. So I'm going to give the word to Javier on how to make it less costly.
Hey guys. So in my personal experience, I've seen that it depends on how the teams are approaching the tools that are given. Sometimes you have like too many tools, you actually pay them, and you don't really care about how many tokens you're using, etc. What I noticed was that if you try to bring a structure to your session, mostly try to understand specifically what you want to do in the day. So if you want to do research work, for example, you really create context files for specific sessions that you are going to have during the day. That's where it comes to what needs to be expected. That's why the context engineering is very important, because you create basically a context for each session that you're going to have during the day. You also, because you understand more or less what needs to be achieved within the session, you can tell the agent, okay, you are not to iterate more than 2 times, because it is very straightforward. If you're iterating more than 2 times, you're probably going to hallucinate. It's not something that you can always know, but it happens a lot. So this way you give the agent a specific boundary. So you say, okay, this is actually the work that I need from you. And of course, you need the checks in the end to be sure that in the end you are achieving the goal that is supposed to be reached in the session. And most importantly, because this is very important on the coding agents, they tend to have their own ideas. They tend to want to understand exactly what you want, and sometimes the output that you are expecting is very specific. So you can say, you can give the structure to the output, and then once you know specifically for the context of the session, in the session that you're working on, and the specific structure for the output that you're going to get, you get a full structure almost of what the session is going to be. And then you see in the end, like this is just one session. Let's say you have 3 sessions in a day. You already had a structurized from the very beginning to the end. And let's say then you take it to a month. You had already structurized all the sessions within a month, and most likely is that the amount of tokens that you are going to have for the specific subscription given by any of the clients that you're going to be working on, or the subscription that you decided to pay for, that you're even going to have more tokens that you previously had, because you decided to do a more structured work within the work that you already had in your mind. That's all I have on token economy. If you guys have any questions, let me know.
Waiting for the questions, and then we'll move on.
Yeah,
but I think,
we have a number of questions, but not specifically on token. Or sorry, Tone is just on the coming in with a question on tokens. What is your experience with switching models? For example, switching to a cheaper one. In theory, this is just switching the endpoint, or does it also impact your setup, harness skills, etc., that you need to refactor? Sorry, not really a token question, but
yeah, I think it is a combination. So yeah. This is one of the topics that we mentioned it on the token economy chapter. In the end, it is about the intent, and it's also about how much what is the goal that you want to achieve. So sometimes research works, for example, don't require to use Fable, Cloud Fable, for example. It's not really needed. So you could decide to create context files with a mini version from GPT 5.4, for example. That would be enough to create context files. So in theory, or it's about understanding your own work. You need to define the complexity of the work that you're going to do, and then you can decide, okay, you have to test it, because it really depends on how big your context is going to be. But in my experience, if you are using the same model for everything, then you are not using it wisely. And also, if you are you can do your own in your context, you can also use like tools such as this one, for example. Let's see, yeah, this one. This is also mentioned on the white paper. So it helps you use the tokens in a better way if you're doing research, if you're doing a specific task to start your session. Because in the end, in your session, if you're going to be coding, then you better use the Sonnet or one of the the models that you're most comfortable with. But when you're creating context, and this is very important, then you don't always need the full capacity of a Fable model, of a Sonnet model. Sometimes you can use even much simpler models. So that's very important, and even tools to actually create the context that you're aiming for, and then jump on to to the session. And then in the session, you can start steering the coding agent exactly the way you want it, or the direction that you want it to go.
So Tone, I hope this has answered your question. Yeah.
I think also to give an example from my work environment is that we have a budget of 30 euros per month, which is not a lot. So we have to be really careful with which models we use. So for planning, we use Sonnet 5, which has a bit more reasoning. So creating the initial spec and the context. And then for execution, we defer that to a cheaper model, because if we really create a concrete and very specific plan, then cheaper models can do that implementation pretty well. Which let me move on to the next slide, which is
just to give you a heads up. I think we have about 4 questions for the end of the session already. So
okay,
just so you know, time wise, yeah.
Then I will move a bit faster without skipping the important bit. So once we have all the changes made during the agent, we have to look at 2 things. So the one side is observability, so knowing how did the agent actually completed session. So of course we don't have to read all the reasoning logs, but what might be interesting is looking in, hey, which tools did it actually call in the chat, and were those tool calls effective? Example for my private project is that, for example, my node is not correctly configured. So what the agent did, it will first check the environment for a node installation, and then come to the conclusion, hey, it's not here, so I will use a rounded path. And I see the same tool call coming back every 3 runs, which gives me a signal, hey, maybe I need to make sure that the agent can actually use a dedicated tool for that, and that saves me some additional tool calls. So that's why you also check the session of the agent, which is not necessarily available to the reviewer. What is available to the reviewer, or should be available, is to create a concrete evidence bundle. I have a skill called evidence-based work, which basically forces the agent with every change that it made to also come up with evidence why that change worked. So for example, it fixed the session login message. It can show me, okay, I ran this unit test specifically to check the session message. And if I would take it even a step further, which is also more costly, say, okay, provide me a screenshot on how it looks like in the front end. And then as a reviewer, I can immediately accept the change without having to open the pull request, run the front end, test the change, if that's already collected. But for everything that the agent needs to collect, it will cost you tokens. So there's a balance. And some of these things can just, of course, be static, which you can just check as a human without necessarily needing to delegate it to an agent. For example, SonarCube or linting, styling rules, spell check, things like that. So observe the run, but also be able to review the artifact as a reviewer. And that reviewer is not necessarily yourself, but might be another colleague. So then, once the PR is opened and the agent did all the work, you as a human, of course, have to decide, will this PR survive production? So we have to check, does the change match the intent? So is the original, did the change complete what the intent says? Is the evidence added by the agent, does it support the behavior? And if not, do we accept that there's not enough evidence, or do we investigate if it really works? And if there are still risks and unknowns, because of course you can't know everything beforehand, is it acceptable enough that we try it out? So the more trustworthy you can make these judgment calls as a reviewer, the more autonomous an agent can work. Speaking about autonomy, what we see is that if you follow this white paper and start working with more agents, we as an engineer move up to a different level. So if you're currently spending 90% of your time coding, I would really scratch your head and say, okay, is this the thing I still want? So what I notice is, well, I think I haven't written a line of code within the last 6 months. So I'm spending less time on actually producing code, but more spending time, well, on reviewing code, but also defining is the change how a change functionally and technically should work, but also designing these boundaries and loops for the agent to follow, so that we really metaphorically create a roadway where the agent has to walk over to get towards this change.
And also, if you want to know more on the engineer the future perspective in detail, we also have a specific white paper on that for people that are interested. Yeah.
So what's important for the engineer is that an agent can make the change, but we as an engineer decide what conditions should be applied before that execution can be trusted. And then we talk about autonomy, which is also, I think we have a bigger ladder within the white paper itself, which is 6 steps. But for every task that you do with an agent, you can set which level of autonomy you have. And each level of autonomy should be earned based on trust within your engineering environment. So the first level of autonomy is basically assisted coding. So we execute and the agent provides suggestions. So that I think that's like 1 year ago with the smart auto completion, or you go to ChatGPT or another tool for advice, and then you execute it as a human yourself. So the coding agents, those are more task driven, where an agent makes the edits, and we as a human basically supervise. Supervise can be you really follow the reasoning log and you jump in when you see it going wrong, but it might also be okay. We have the intent, you give it, and in 4 hours you check back what the result is. Which also basically is more towards the next level where you let the agent run in a bounded loop, so you have a really clear goal in mind, and then you gate the outcome. And the last autonomy step is really making sure they can run autonomous. So I think Javier also shared a good example in his production case where they have Sentry monitoring their system, and based on a trigger, like an exception within their production stack, the agent automatically starts coding and solving that exception, which can result in like zero downtime or near zero downtime for your users.
Yeah, and Roel, Xing also asked the question, do we at Team Rockstars have a paved road to ensure the AI and we as humans don't go off the road? Can you elaborate on that a bit?
Maybe a good question for Xing itself to elaborate. What does he mean with paved road?
We'll ask that. I think he will
I assume like
listen.
golden path or something, right? I assume that's what it means.
Yeah.
Like a best practice.
We'll give Xing a moment to respond and then we'll come back to it later. Yeah.
Exactly. So once you have decided, so the thing with the autonomy is not every task deserves the same autonomy. And it's definitely not the goal that you have your entire system running in full level 4. There's still things that need human oversight. So that's either level 2 or maybe even level 1. And then, so that was also a question. So the scope of this white paper is really having an intent, run it, then a PR. An example I just made with Sentry says the next level beyond this white paper would be loop engineering. It's like, if you look for it, it's a new term that was coined, I think around the same time this white paper was written. And in loop engineering, you really create autonomous workflows within your software development lifecycle, where something based on a trigger, the agent will pick a work and that either create a PR or directly modify it on production. And then multiple teams will have multiple loops running, which creates more autonomous agent teams. And that's also what I see in the future. So besides just having humans in your team, we'll have also have agent teams that can multiply your capabilities, but used wrongly, they can of course scale the failures. So something I already experienced even before we have agent teams, we as a human, it's not doable to catch up with all the code reviews that's being generated. And if there's a bad assumption somewhere down the line and the agents keep working towards a bigger goal, those assumptions propagate throughout the entire system. So we really need a good policy system to know will the agent team have success or not. But on one hand, with good agent teams, you do unlock more parallel tasks. One engineer who can pick up multiple projects or even do multiple work at the same time. And then we can, of course, change broader delivery goals. Do you want to add something, Timo, to this one, or?
No, not really.
Okay. Then
sorry, I was reading
I think,
messages in the chat.
Let's dive into the QA. So to give you a call to action, what current part of your system is not autonomous enough that you can hand it to an agent? That's something for you to investigate. And what an agent helper, and what conditions do I need for an agent to be able to successfully contribute to my development stack?
Thanks so much, Roel. I think we have the last 8 minutes for some questions. So question of Marco. We had to wait 20 minutes almost, so let's give it a go. There's a lot of change of tools, methods, techniques, of course, continuously. How do you make everyone within a team or company using the more or less the same techniques? So how do you make sure everyone runs in the sandbox environment, use well-defined agents and skills, use only specific MCPs, the right LLMs, don't use too much tokens? Do we use AI coaches or something for your teams? How can you respond to that?
So a broad question, and we'll try to keep it short. So what we do at my customer is that we had a real good conversation with our team. So okay, how do we want agents to contribute? So that's also a question you should ask to your team. Okay, how do we want to have it contributed? And if we know where we use agents and not, how do we make sure everyone uses the same tool? So agents and skills and tooling, those are checked into the repository itself. So everyone who works with the repository has the same agents and skills. I don't really have an answer for specific MCPs yet, because we have MCPs disabled, which makes it a bit more difficult. But I think, no, Matthijs is not here, but I think the people who wrote the AI gateway paper, they do have something about also using approved MCPs only.
Yeah, there's some points in there, exactly. Yeah.
Yeah.
I mean, we see in our agile community that a lot of our Scrum Masters and product owners have made a shift to making sure teams work together in a proper AI way. So I think there's a movement going on there that will continue when we go ahead. Yeah. I don't know if they call themselves AI coaches yet, but I think it will go in that direction. Okay, next question, Marco. I hope you have some answer to your question. Now, Velk asked questions. What about local AI models and using them as reviews with the right instruction set of training? Especially now, local AI models are getting better and better, including for coding. Do you have any recommendations or tips for that?
For me, often local AI is still too slow for review. I notice, like, it's good for reviewing like a single file or a few files, but yeah, larger MRs, I feel it still struggles unless you really have like a 256 gigabyte local AI server. Then of course it's a different case. But I have only like 48 gigs in my MacBook, and for code reviews, it's for now not good enough yet. I sadly notice. Yeah.
Locally, what I often do, if I don't have let's say I don't have a cloud subscription, I tend to use diff files to try to, review my own work and then create different context files to try to give the agent the exact context that is needed to get some feedback. Normally, it's not the expected feedback that I want to get. I normally get a better feedback when it's a cloud model, such as Sonnet or Fable, for example. But it is doable. So I could work without a cloud subscription, for example, if it's needed.
And a question on the same part from Bram. How do you handle AI and privacy? Yeah? So are there any, do you ever experience some struggles with that, or how do you make sure that your governance is all on point on that?
For me, it's just it's really simple in the way that we only use approved AI coding agents. So from our organization, we only have the license to get a Copilot, so that's the only agent that is contributing to this repository. At least from our team, I know a lot. There are other teams that use Shadow AI, but that's outside of the scope. But I think the next step, what I will see for the organizations that they use an AI gateway to really bring your own models to coding agents, so that the organization can really stay in control which models and which requests get sent to the cloud.
Yeah, you will have to do that more on a high level basis within the company, probably.
Yeah.
Yeah.
Yeah, and also personally, I always try any PII stuff. I almost always do locally. Especially usually these are also more simple, right? And for code, I have less feelings of it going to the cloud, but for personal information, I try to keep it out of the cloud at all costs. Yeah.
Thanks, Timo. Okay. So I will try to do 2 or 3 more questions. Gijs is asking how efficient code reviewing agents really are, because you still have to confirm code yourself. Isn't the best idea to have code reviewing agents look specifically for edge cases and other stuff that we as humans easily tend to not oversee?
I'm going to answer this one, but I think you answered your own question perfectly. But at our work, we have GitLab Duo, which automatically reviews every pull request. What I see is a shift happening is where the static code analysis, like SonarCube, they find all the quality issues, and we have a spell check and things like that, but really statically. And the agent judges basically on how well, other quality stuff, which is more dynamic. So, hey, I see 2 changes that contradict each other, and then it asks the developer, okay, which one should it be? And then for me as a human reviewer, I mostly check, does the change match the intent of the PBI? So actually, I'm more moving towards like being a tester and checking if the change actually complies. And one thing that I do notice that agents those review agents are pretty bad at still is like, okay, is there like an architecture boundary invalidated? I usually have to check on that.
Thanks, Will. I think we have to leave the other questions. I think we addressed most of them. Xing, I see your answer, but I think I see a lot of people leaving now because they have a follow-up meeting at 1 probably. So we're going to close this off, but Xing will make sure to get back to you from these 3 guys. If you want more deep dive, please check the webinar, the white paper, of course. It's available within this QR code. Next Friday in a week, we'll follow up with the agentic coding webinar results, where SIG, Software Improvement Group, has also reviewed the agentic coding. So it's really interesting to join that also. And on September 21st, we will do this webinar, so the same webinar as today. So if you have any people who you think will be interested, please send it to them. So I hope you enjoyed. We don't know everything within Team Rockstars about agentic coding or as AI-assisted coding, but thanks to these guys, we know a little bit more every day. So thanks for joining us, and great job everyone on asking the questions. So we really enjoyed this.